At this point, we've seen that we can set whether or not we want to show the decimal point. We've also seen that we can change the precision with a couple of examples on how that will affect our output. Now, what if we don't want the output to be displayed in scientific notation? Well, we can set the output so that it is displayed in fixed point notation. So I'll just go and copy this. Basically, if we set this to fixed point notation, then we will not have scientific display. We can do this in two ways using the member function on console output. We use setF for set flag. This is in iOS. That is in iOS fixed, so we pass that in to set the flag. For that, it is important to note that with this fixed flag set, that the number of digits in the decimal part is represented by the precision, and we will get no exponent part. In other words, the precision is going to differ between the default representation and the fixed and the scientific notations. With the default floating point notation, the precision is going to dictate the number of digits displayed both before and after the decimal point, as we've seen in previous examples, while in the fixed and in the scientific notation, the precision that you have set is going to dictate how many digits to display after the decimal point, even if that means that you will get trailing zeros. If I build a run now, again we get the default display, and then we get the fixed point notation. Now with this we actually do get the decimal point, as you can see, but it is not output in scientific notation, so we do not get the E, for example. Alright, so setF is one way of enabling the fixed point notation, but also in the iOS, as we've seen, this is in the iOS, so we don't have to go and include the header at the top, because we are including iostream, and that is basically already part of iostream. If we include that, and we already have access to iOS. So with that, what we can do is we can do standard fixed. I'll actually just remove the using namespace at the top here, and I'll add a new line over here. Following the standard fixed, we will get a fixed point notation. So I can build around that, and as you can see, that is the same as what we got previously. And then of course we also have a scientific notation. And we can set that using the standard scientific, and this is also in the iOS, so again we don't have to include iomanip or anything like that. That here comes in through iostream. And I'm fully qualifying everything here, so we have standard console output, standard scientific, and so on. With the scientific flag set, floating point values will be displayed with only one digit before the decimal point, followed by the decimal point, and then we'll get as many decimal digits as is set in the precision. Again, remember the difference here between the precision as it relates to the default output, that is the default floating point notation, and the scientific and the fixed notations. The scientific notation is also going to include the exponential part, which, as I explained in the module C++ 101, consists of an E, followed by an optional sign, and the exponential digits. Okay, let's build a run and see the difference with these. So we get fixed point notation, and of course again see the difference here with scientific notation. We get one digit before the decimal point, and then the rest will show up as we are familiar with already with scientific notation. Okay, now let's say we have a couple of flag sets. So for example, currently we have standard fixed set, we also have standard scientific, you can have other flags as well. How can we unset that? Well, you can look at this. For example, we have setF. If you think about this for a second, we should also have an unsetF or unset flag. Also, I'd like to mention that if you don't have using namespace standard at the top, then of course you might need to make sure to fully qualify that in here. Now what I'll do for this demonstration is I'll go and select these, press and hold Alt and move those all the way down. And basically what I want to do is I want to revert to the default output or default display. Let's say we are currently outputting to scientific notation, and we also have the positive sign showing up. We have both of those now. I'll build a run so we can see what this looks like in fixed point notation and then also in scientific notation. Now, as I mentioned, we want to revert back to the default display. And actually, I'll just make one of these a negative value. So the first double I'll set to negative 1, 2, 3 here. And then I'll go down and we can look at how we can revert. In this case, we know we want to unset the scientific, so let's start with that. Again, that is also in the iOS. So we qualify that standard iOS scientific. And if I build on now, let's see what we get. Again, we get the fixed point notation, we get scientific notation, but in this case we get the signs as well, and along with the positive sign as well. Let's say we want to remove that positive, because now that is still showing up down here. That is not part of the default display, as you recall. By default, we only get the negative sign printed out. Okay, so let's go and look at how we can set that. I'll just go and copy and paste that. That is show POS for show positive. So I unset that flag as well. Let's see if that works. Build a run, and you can see that the positive sign no longer shows up. Now I would like to show you a quick trick here, and I'll comment this out. And I'll copy this. I'll do a single vertical bar, and then I'll paste that in. So now I'm doing both of these. And that's because we have this mask, which can accept multiple things. So we do this, the bitwise OR, which is a vertical bar. And basically this unset flag is now going to unset both of these. Build a run. And now you can see that we basically get the default display as we would expect from the default console output. Just fix my window here. As I mentioned, we have this. Just Control Shift Spacebar. We have this type here, FMT flags. The name for that is _mask. That is a type that is going to represent stream format flags. The unset flag, the set flag, and also a flags member function uses that FMT flags as a type in its parameter, and in some cases as a return value as well. Let's just do one more example with that. So here we are doing two using scientific and the show pos. Now I'll just go and comment those out. To save some time, I'll copy that line and then I'll go and paste that in here. And then I can set the flag. So set flag. I'll do Control Shift Spacebar, and you can see that that also takes in the new FMT flags. Okay, and that is also of this type, FMT flags. Those are basically constants that we can set, and we can combine those in a single FMT flags value using again this bitwise OR operator. And actually, instead of using set flag here, I will go and use something called flags, the member function flags. The flags member function is going to set the value for all of the format flags in the stream. It will overwrite any existing values and it will clear any flag not explicitly set in the argument. Okay, so from here again you can go and do individual flags if you want, using setF or unsetF for set flag and unset flag. Because if you go and use setF here, for example, build a run, we'll get a weird output here. We will not get the scientific notation as we would expect. So of course what we can do is we can go and unset the iOS fixed, and then see if the result is any better. That seems to work fine. But as we've seen with the previous flag here, I'll just comment that out and use flags instead. That is going to eliminate that step, alright? You might be thinking, can we do this unset flag and unset these flags using the public functions instead of the console output member functions? And that is what we are going to look at next. So let's get started at the top here, and I'll go and I'll just remove all of the stuff here. And what are we doing here? We are setting flags. And we are setting those flags on the console output. For this, we'll actually have to include the IO manip, but I just want to show you here that we need something called set iOS flags. Okay. And again, for that to show up, we actually need to include the IO manip. And it's also going to be the same thing if you want to reset those flags, which I'll talk about in a second. We have set iOS flags. You see in the squiggly just go away over there. And notice if I do Control + spacebar here, as a formal parameter, this has that FMT flag space again. So what we can do is, we can pass in both of these, like so. Then we can just go and get rid of that line. So we are doing set iOS flags. We set these flags, scientific and iOS, for that is show positive for the positive sign. Then we want to go and unset those again. Just go and copy this line here. And in this case, we want to reset iOS flags. Reset iOS flags is similar to the unsetF member function. So I can now go and clean up. I can remove this unsetF line here. And I'll actually also go up and remove this comment where we did the setF. This is what we have now. We have set iOS flags to set those flags, and we can do reset iOS flags to reset those flags. Here I can also use standard fix to set the fixed point notation. But if I build and run now, we actually will not get the output that we would expect with the scientific notation. And also notice that the default display here is also not what we may expect. This is more similar to what we have up here with the fixed point notation. So maybe take a second, pause the video, and think about how you can fix this. Alright, I'll just continue on here. Of course, we need to go and unset the standard fixed flag again. So I'll use this reset iOS flag. That is, instead of using the unsetF member function on console output, I'll go and use this, and then I'll go and reset that fixed flag, and then I go and set those two, and then I want to go and reset those two again. And this should work fine now if I build and run. Firstly, we can see that the default display shows up as we may expect. We do not get the positive sign showing up, and we also do not have the fixed point notation as we had before. In other words, we do not have the decimal point and a bunch of zeros as we had in the previous output. And then for the scientific notation, this seems normal now. To wrap up, I would like to note that there is a difference between the manipulators and what we pass in here. For example, we have standard fixed up here. Okay, that is a manipulator. But what we pass in here are member constants. So manipulators are global functions, and these that we pass in here are member constants. The member constants are publicly defined in the iOS base class. For example, I can go and do iOS_base, okay? Those things are defined in there. So the manipulators that are in the global scope might have the same name as those constants that are defined in iOS base. And actually, I'll just quickly build here to show you what I mean that is going to work. And you can also use a derived class because, of course, the derived classes are iOS base classes. And that's why we can use iOS base or iOS. Or as we've seen, we can use the instantiated objects such as console output, where we can do cout.fixed and so on. Why is this important? Well, if I pass in a manipulator instead of the constant, as I do here, standard fixed, and of course if I try and build now, we can see that we will get an error. So I'll just undo. Alright, so we want to reset the iOS flags, and we're going to pass in that constant here, and we want to set those flags here again, and then we want to reset because we want to get back to the default display. And if I build a run, we can see that that prints out as we may expect. I have summarized this for you in some of the introductory lectures in this lesson, but just to reiterate, we have the public member functions on cout and cin, for example. Then, as we've seen in this lecture, we also have public member constants, which are used as arguments for the iOS base, that FMT flags. For example, we can do standard iOS base show base. Then we also have the global manipulator function invocations, and we don't qualify those to a class because they don't belong to a class, they are global functions. In the final example we have, that is in the console output statement, we have standard set w for set width, and we pass in 8. We will take a brief look at some documentation again. So on c++.com we have the standard iOS FMT flags documentation, As you can see here, this type is used as a parameter and or a return value by these functions flags setIf and unsetIf, and then the values passed and retrieved by these functions can be a combination of the following constants. So you can see the constants in here, and many of them have the same name as what we have with the manipulators. Alright, and so it has some examples on here. So this is a good reference to have handy when you are working with this, so I'll provide a link to this.